Bismillahirrahmanirrahim. In this lecture, I am solving problem 5.36 from the book Fundamental of Thermodynamics by BORGNAKKE. So the statement of the problem is a 100-liter rigid tank. 100 liter mean the total volume is equal to 100 liter, and we know that 1 liter is equal to 1 decimeter cube. So 100 liter is equal to 100 decimeter cube. And to convert dm cube to cubic meter, divide by 1000 cubic meter. So volume is equal to 0.1 cubic meter. And rigid tank mean that volume is constant. Rigid tank mean that volume is constant. So total volume at state 1 is equal to total volume at state 2, which is equal to 0.1 cubic meter. Contain nitrogen. Working fluid is nitrogen at 900 Kelvin and 3 megapascal. T1 is 900 Kelvin, and in degree centigrade this is equal to 900 minus 273 degree centigrade. So T1 is equal to 627 degree centigrade. So this is in Kelvin and this is in degree centigrade. And P1 is equal to 3 megapascal. 3 megapascal mean 3000 kilopascal, because 1 megapascal is equal to 1000 kilopascal. The tank is now cooled to 100 Kelvin. After cooling, the temperature T2 is equal to 100 Kelvin. What are the work and heat transfer for the process? Required is to find work and heat transfer. So as we know that work is equal to integral of 1 to 2 P dV, and dV volume is constant as V is equal to constant. So change in volume V2 minus V1 is equal to 0. So work done is equal to 0. For constant volume process, work done will be 0. Now for Q, from first law of thermodynamics, Q minus W is equal to mu2 minus u1. So W is 0, so Q is equal to mu2 minus u1. So first we find mu1 and u2. So for state 1, there are two states, initial state and final state. So from states 1 we can find u1, v1 and mass. So here initially temperature is given to us and pressure is given to us. So first we check whether it is in mixed region or in superheated region. So from saturated table of nitrogen, from saturated table of nitrogen at pressure P1 is equal to 900 Kelvin. Find saturation temperature. So check here. This is superheated. This is superheated. Let me check it in saturated. This is saturated nitrogen. Saturated, and here this is temperature in Kelvin. Pressure is given to us. Sorry, we will check this. Pressure 900. Sorry, this is wrong. Pressure. Sorry, 3000 Kelvin. In front of pressure 3000 Kelvin, find saturation temperature. So this is almost 3000, more than 3000, and at this point the saturation temperature is 125. It means that at 300 it will be less than 125, almost 122 or 123 Kelvin approximately. But the temperature given to us is very much from this 900 Kelvin. Is T1 given to us is 900 Kelvin, which is very greater than Ts. It means that T1 is equal to 900 Kelvin is superheated temperature. So T1 is equal to 900 Kelvin is superheated temperature. And to find U1 and V1, we will use superheated table of nitrogen. So from superheated table of nitrogen at pressure P1 is equal to 3000 kilopascal and temperature T1 is equal to 900 Kelvin. Find U1 and V1. But this 900 Kelvin is not available in the superheated table of nitrogen. Temperature is in degree centigrade, and this is equal to 627 degrees centigrade. So we will do interpolation. So 3000 kilopascal is available. So at 3000 kilopascal in front of temperature, find specific volume and internal energy, kilojoule per kg. So in superheated table of nitrogen 600 and 700 are available, but we have to find the V1 and U1 at 627. So let me check it. So this is the superheated table for nitrogen, and this temperature is in degree centigrade. So and this is the 3000 kilopascal, and 600 and 700 degrees centigrade are available. So we will do interpolation between 600 degrees centigrade and 700. So in front of 600 degrees centigrade, volume is 0.06013. V1 is 0.06013, and in front of 700, volume is 0.07012. 0.07012, and we have to find V1. Similarly for U1 in front of 600 degrees centigrade, this is the value of U. These are the values of U. 446.57, 446.57 kilojoule per kg, and in front of 700 degrees centigrade, this is 525.99, 525.99. And we have to find U1. So do interpolation. So first interpolation for V1, third value minus first value divided by third value minus second value is equal to third value 0.07012 minus first value divided by third value minus second value, which is V1. So find V1 from this. So V1 is equal to 0.0628 meter cube per kg. Now this is V1 specific volume, and total volume V1 is given to us. So it means that as we know that specific volume is equal to total volume divided by mass. So this implies that mass is equal to total volume divided by specific volume. So total volume is given to us as 0.1 cubic meter. 0.1 cubic meter, and specific volume is 0.0628 meter cube per kg. So cubic meter will be cancelled with cubic meter, and mass is equal to 1.592 kilogram. Now per U2 we are doing interpolation per U2. So for U2, third value minus first value, 700 minus 600 divided by 700 minus 627. 700 minus 627 is equal to per U1, third value minus first value, 525.99, 525.99 minus 446.57 divided by third value minus second value, which is U1. So do interpolation and find U1 from this. So U1 is equal to 509.69 kilojoule per kg. Now for state 2, from state 2 we can find U2. So first we check whether it is in wet region or in superheated region. So from saturated table of nitrogen, as T2 is given to us as 100 Kelvin. Find V2. So find Vf and Vg. Vf and Vg. So at 100 Kelvin, this is the saturated nitrogen and this is 100 Kelvin. At 100 Kelvin, this is Vf 0.001452. 0.001452 meter cube per kg, and Vg is equal to, this is Vg 0.03120, 0.03120 meter cube per kg, and V1 calculated by us is 0.0628. So 0.0628 is greater than Ug, as V1 is equal to 0.0628 meter cube per kg is greater than Vg. So state 1 is in superheated region, and we can draw it on TS diagram, on TV diagram. This is temperature in degree centigrade. This is specific volume in meter cube per kg. This is saturation curve, and initial temperature is 900 and superheated. This is initial point and this is 900, and final point is more than Vg. So this is final point and this is temperature, constant temperature line 100 Kelvin. So this point is Vg, but V1 is equal to V2. V1 is equal to V2, constant volume line. So as V2 is greater than Vg, so it means that second point is also in superheated region. This is V2. V1 is equal to V2, constant volume process. So we will use superheated table to find U2. So from superheated table of nitrogen at pressure P2, P2 is not available, as temperature T2 is equal to 100 Kelvin and volume V2 is equal to 0.0628 meter cube per kg. Please be noted that V1 is equal to V2. You can write here as this is V1, so we constant volume process V1 is equal to V2 is equal to 0.0628 meter cube per kg. Now we have to find U2 at temperature T2 is equal to 100 Kelvin and V2 is equal to 0.0628 cubic meter per kg. So if we check table, 100 Kelvin is available in the superheated table. This is superheated nitrogen, this is temperature in Kelvin, and this is 100 is available, but volume is 0.06806, and here at 100 Kelvin volume is 0.04299. So we can do interpolation between at 100 Kelvin between these two volumes, and find U2. This is at 0.06806, internal energy is 69.3, and 0.04229 internal energy is 66.41. So we will do interpolation between these two below. So at 100 Kelvin, at 100 Kelvin, do interpolation between volume V2 and meter cube per kg and U2 and kilojoule per kg. So if we check the table here, at 0.04299 volume, 0.04299 volume, internal energy is 66.41, and secondly at 0.0, and both temperature is 100 Kelvin, in both cases temperature is 100 Kelvin. At 0.06806 internal energy is 69.30, and we have to find internal energy at volume 0.0628 U2, and in all cases temperature is 100 Kelvin T2. So do interpolation. So by interpolation, third value minus first value, 0.06806 minus first value divided by third value minus second value, 0.0628 is equal to third value 69.30 minus first value divided by third value minus second value, which is U2. So simplify this and find U2, which is equal to 68.69 kilojoule per kg. Now we can easily find Q, heat transfer. So Q is equal to M into U2 minus U1. So Q is equal to M into U2 minus 1. So M is already calculated by us, which is equal to 1.592 kilogram. U2 is equal to 68.69 minus U1 is equal to 509.69 kilojoule per kg. So Q is equal to, simplify this and find the value of Q. So Q is equal to 69.69 68.69 minus 509.69 multiplied by 1.592 minus 702.072 minus 702.072 kilojoule 72 kilojoule, because this kilogram is cancelled with this kilogram. And negative sign mean that heat is a negative sign mean that heat is rejected, because cooling, there is cooling in the process. And this is the TS diagram, TV diagram for this. From 1 to 2, temperature decreases from 900 to 100 Kelvin. It means that the heat transfer must be negative. And this is the end of the problem. And for more problems, please like and subscribe my YouTube channel and share with your friends. Thank you.